Welcome. Let's take a look at another example here. A multiple choice quiz consists of 8 questions. For each question, there are 4 possible choices, A, B, C, D, one of which is the correct answer. So suppose a student randomly guesses on each question, and we'll let X equal the number of correct guesses. All right, so for this binomial experiment, the number of trials would be 8 because a student will be guessing 8 separate times on these 8 questions. And then P is the probability of a successful guess. So getting the question correct. So if there are 4 choices and one of them is the correct answer, then the chance of guessing correctly would be 1 out of 4. And let's just go ahead and put that in decimal, so 0.25. So Q would be the probability of a failure, which would be 3 out of those 4 would be the wrong answer, but I'm going to go ahead and use my rule of complements. So Q is 1 minus P. So working in decimal, 1 minus 0.25, 0.75. So a 25% chance of guessing a question correct, a 75% chance of guessing a question incorrectly. And then we'll find some probabilities. So what I'll be doing here, since we know how to find the functions on the calculator already, I'm just going to be putting in answers and you're welcome to check. But the focus here will be on writing that question correctly, and then we'll put our graphing calculator input. So let's check it out. So find the probability that at most 4 of the guesses are correct. So at most 4 means 4 at the max. So X is our variable for correct guesses. At most 4 would be less than or equal to 4. So here are the possibilities. So a student could get none of them correct, all the way up to possibly getting all 8 correct, but we want at most 4. So at most 4 would be 4 of them, or 3, or 2, or 1, or 0. So in that case, we use our binomial CDF, which will add those individual probabilities for us. And then we enter N, P, and K. So again, if you'd like to use this convention using K, so at most K, we have our value K as our input into our binomial CDF. All right, and as I said, you're welcome to check that on the calculator. I'm going to just write our answer here for us. That will be 0.973. And I'll just leave it in decimal, but that would be a 97.3% chance. Pretty high chances they get at most 4 out of those 8 correct. Okay, let's take a look at our next case. What is the probability they answer less than 6 of the questions correctly? So less than 6 of their guesses are correct. So less than 6 would be X less than 6. So less than 6 would be getting 5 or 4 or 3 or 2 or 1 or 0. So in this case, the ending number is 5. So it won't be 6 when we get to our binomial CDF. So again, if you want to refer back to the rules, when the probability is that X is less than a value K, we can use binomial CDF. We just have to remember that we don't put in that value of K, we do K minus 1. So we're ending at 5. All right, so that value that we're putting in is K minus 1. All right, and that answer, again, if you'd like to check, should be 0.996. All right, so this probability is a little higher than that one because we're adding in another possibility. All right, C. What is the probability that more than 5 guesses are correct? So probability that the number of correct guesses is more than 5. So coming over here to circle more than 5 correct would be 6 or 7 or 8. And so this is the case where we apply the rule of complements, because we can use Binomcdf to find the complement. So it's going to be 1 minus Binomcdf, and that complement we can find by using NP, and the complement ends at 5. So in this case, the more than K, the greater than K case, rule of complements, and you put that value K into that third spot. And that answer is going to be quite a small probability. That will be 0.004. So remember, they're just guessing questions. So out of 8 questions, it's pretty unlikely they're going to get more than 5 correct. Pretty small chance. Okay, next case. The probability they get at least 3 questions correct. So at least 3 means greater than or equal to 3. So greater than or equal to 3 would be 3 or 4 or 5 or 6 or 7 or 8. So we need our rule of complements again. So there's our complement. There's our complement. So we do 1 minus our complement, can be found using Binomcdf. 8.25, and our complement ends at 2. All right, so here you want to remember for the at least case, so greater than or equal to a value K, that the complement will end at the number before K, K minus 1. And then that answer will be 0.321. All right, so let's do a couple more here, but we have our 5 cases. Actually, we don't quite have our 5 cases, we have 4. So we've got our less than or equal to and our less than. Those are just Binomcdfs. We have our more than and at least. Those are rule of complement cases. And now part E, what is the probability a student gets exactly half of the guesses correct? All right, so they're going to be guessing on 8 questions. So getting half of the guesses correct would be getting 4 out of 8 correct. So the probability they get exactly 4 out of the 8 correct. So this is our exact case. So X is exactly 4. So this is the only time we do a PDF is our exact case. And the value for K there is what we put into that third spot. All right, that will be 0.087. Want to check that out. Now we've got our 5 cases. So we'll just do one more here. Probability of 4 or more guesses that are correct. So 4 or more would be X greater than or equal to 4. So 4 or 5 or 6 or 7 or 8. So there's our complement. So we do our rule of complements. And the complement ends at 3. All right, so you don't have to use my template using the letter K if you're understanding it. and hopefully the visual helps here. But just to put in the K again, so for 4 or more correct, so more than or equal to 4, the complement always ends at the number before K, or K minus 1, and then that answer will be 0.114. All right, and hopefully that's a good review there of the various cases using your binomial functions on your calculator.